Good afternoon, everyone. My name is Wang Tian. I'm a master second year student from this lab. Today, I will give a presentation on the study influence of cells on milk composition analysis based on the comparison of attenuated total reflectance terahertz spectroscopy and mid-infrared spectroscopy. This is my presentation outline. In this presentation, I will make a brief introduction to my research and show some results and discussion of this research. And if there is still some time left, I will talk about the additional part for the master thesis. This is the items I used in this presentation. This is the abbreviation items. As we know, somatic cell count is the largest composition in milk and is an indicator of cow's health and milk quality. No matter the cow has mastitis or not, a somatic cell will exist in milk. And because of the somatic cell is very large, so conventional spectroscopy method is not suitable for detecting the SCC in milk, such as using mid-infrared region and using near-infrared region. So previous researchers using fluorescence with stain reagent to detect SCC, but it's a very time-consuming, expensive, and not easy for the real-time monitoring for milk quality method. And based on that, later the researcher in our lab has investigated the terahertz spectroscopy method to detect the SCC value. And in his study, he shows a potential result. Now I will talk about what's the difference between the terahertz spectroscopy and the mid-infrared region. Terahertz wave lies between electronic waves and optical lights. This region contains a lot of information of intermolecular vibration such as hydrogen bond and van der Waals. Where in mid-infrared region, the target is the intramolecular vibration, such as chemical bonds. So mid-infrared region is very useful for identification the chemical and classification because it's very sensitive for the functional group of the molecule. But here, milk inspection with the terahertz spectroscopy is a new technology. By using terahertz spectroscopy to detect the milk, there is a possibility that we can get some new information from this region. But there is a big problem exists. That is, the water has a very strong absorbance in this region. So the conventional transmitter method is not applied in this region. To solve that problem, we can use attenuated total reflectance method instead. This is attenuated reflectance. This is our device, the silicon and the cell. When the light comes through the interface, if the incident angle is big enough, so all the light will be reflected totally. But meanwhile, the evanescent wave will generated. So by this equation, we can calculate the evanescent wave penetrated depths in this sample. Based on this equation, I estimated the terahertz region penetrated depth is from 3 micrometer to 30 micrometer, and in mid-infrared region is less than 3 micrometer. As we know, the somatic cell diameter is about 10 to 20 micrometer. So it's just like this. This red one is a cell, and the yellow one is small molecular, such as protein and other composition. So we hypothesis that cell existence will make some influence on the accuracy of the milk composition examination. Here is my objective of this research. Based on the previous research, I I want to investigate the influence of milk cells with different concentrated somatic cell counts on the accuracy of terahertz and mid-infrared spectroscopy determination of fat, protein, casein, lactose, solid non-fat, urea, and ICC. In my research, I used 145 raw milks without processing and homogenizing from Hokkaido. This is the actual data of core milk composition. We can see ICC values varies in a very large scale, but where the other components basically concentrated is stable. Now I will show you some result and discussion. First is the fundamental part of my research is water absorption from UV to terahertz region. This is the water absorption coefficient I obtained from the reference list here. And from this reference, we can see that in the UV and the visible region, the absorption coefficient of water is extremely low, and also in terahertz region, the absorption coefficient was very high. Now I will show the experimental result obtained from our lab. This is the experimental result obtained from our lab. We can see here is a terahertz and mid-infrared region I brought up here. This result coincidence with the previous result. The result is very good coincidence. But in this region, it means UV and visible region, our device shows some limitation. We get negative value. So based on that, based on this equation, here this A refers to absorption of water, and kappa means extinction coefficient, just related to the previous reference I showed. We estimated the absorption in UV and visible region of water. The blue line shown here. So this research can be used for the experimental compensation in my afterwards experiment. Now I will show you the second result and discussion is cell influence on milk composition examination. The first one is a low ICC group. We can see the scale of log ICC is from 0.477 to 1. In this experiment, I'm using cross-validation to process the data. This is all the original data without pre-processing method. And we can see, except the log ICC, the cross-validation correlation coefficients from terahertz and mid-infrared device are similar. In this case, in low ICC group. But in high ICC group, we can say fat cross-validation R square has significant improve, but meanwhile the other composition, all the other composition result get worse. Now I will compare the low ICC group and high ICC group by using the same device. We can see compared low ICC group and high ICC group, the low ICC group shows the better cross-validation value. And also the same result can be observed in mid-infrared device. The same. When the ICC values increase, the cross-validation result get worse. Like this, get worse. Now here is my conclusion. First, from this study, we can prove that cell concentrate has influence on the accuracy on the spectroscopy. The higher ICC concentrate, the lower correlation value will be. And basically, in high ICC group, terahertz perform better than the mid-infrared region. The third one is, as we all know, the mid-infrared region is very sensitive for detecting the small molecular composition. But in this research, we can say terahertz also has a very good potential to detect examinations milk composition. So there is a possibility to combine the terahertz spectroscopy and the mid-infrared spectroscopy to improve the real-time monitor system. The future work of this research is to cross-test for low ICC set and high ICC set to see the further relationship of these two groups. Oh. Now I have time, so I will show the additional part. Okay. This is the additional part for my master thesis. Just now I talk about the main part of master thesis, and in the additional part of master thesis, because I measured the very broad range from UV to terahertz region, I want to combine the mid-infrared with terahertz, NIR, UV, and visible region. First, to see if we can select several effective wavelengths to obtain the higher correlation coefficient and lower root mean square error. And second, by comparing the combination method, we can select which combination method is better and combine measurements to get a faster and real-time milk composition monitor system. That's all for my presentation. Thank you. Thank you for your attention.
Because soon you have defect, so I think it's very important to improve your you use some I think not academic terminology. For example, when you explain about ETR, you say that the range is big enough. So I think maybe you should mention about the principle of ETR, for example, because you know the refractive depth of your sample and the size, I mean the system, and then you saw the physical angle that should be higher than this. So and then you have 45. So that's why you can see. Okay. So big enough is
45 degree. Yes.
Will be question. So big enough.
Okay.
And then also you say when you explain about you compare the statistical data of SCC and others like protein. You mentioned that other data is stable. What is the more stable? I mean, like protein is stable. Stable means that SCC is fluctuating or some.
I mean, the scale is little.
Yes.
Yes.
Maybe not large scale or large. Maybe you better mention in statistical term. For example, you may use histogram to show this data is highly variation. It's not so variation. So maybe I think this will be in academic situation.
Actually, I have a histogram figure, but too many, so I didn't show here. I'm afraid of time.
We have a technique. Hi. Thank you.
Thank you.
Any other suggestion?
Question. When did you take the sample?
From last half years.
In what month or something?
In what
Yeah.
months?
Yeah. Time.
From last year November to this year April. Each time will be 18 to 24 samples will delivered here, and this is raw milk kept in the refrigerator for 1 day, and after it milks in 3 days we keep in the refrigerator and we will measure it. And before marrying the milk sample, we will heat to 40 degrees centigrade, and then we will measure in 3 devices.
This new sample is taken during winter.
Basically, yes.
What do you think if you take sample in summer? Do you think the result will be different?
Maybe summer, if we take in summer, the mastitis will happen more frequently, so the ICC concentrate will be higher. Maybe that's a good future study.
I think you have to mention also that because
Okay.
it's very important.
Milk time.
Yeah.
Any other comments or suggestions? Show us the final slide again.
Conclusion?
Final slide.
Final.
This one.
This one, okay.
This looks mid-infrared. Basically, mid-infrared is recommendable.
Yes.
Then plus terahertz plus visible or UV. So you suggest some combination will be the more effective, something like that.
Yes, because different region can obtain different kinds of information. So maybe we combine several information will improve the result. Maybe.
And in your presentation, first slide to 10 or 11 would be a very good, so very good size and appropriate font. But some of them are abruptly very small letters.
Yes.
What happened?
Especially the figure.
Why so small?
Because every time if I import from the Excel to PowerPoint directly, my computer will die, so I can only copy into the picture.
Okay.
So I can't browse.
Yes, next time you make larger.
Okay.
Also, I have a suggestion, the equation.
Equation.
Any variables should be italic. So, A, lambda, so maybe another equation, you have a many variables.
Yes.
Should be italic.
Okay.
Even R square.
Oh, okay. Okay. I will amend it. Hi.
I did not see the explanation about the reason why. I think it is,
Okay.
yes, of course, by looking at your data, we know that, for example, in SCC, the prediction ability for other components is little bit higher, I mean better than high SCC, but I didn't see
Yes, I didn't put the explanation here because I, as a reference said, in near infrared region, maybe high ICC concentrate will make the, because the ICC will eliminate some chemical bonds, will disagree some protein or other composition concentrate.
No, I mean, it's better in your presentation.
Okay.
Put, and then maybe figure is better and maybe easy to understand.
Next time I will add the small explanation on it.
But I think that's the most important.
Okay.
Because why you separate low and high SCC, and we can conclude that by separation, low SCC and high SCC, for example, low SCC, the ability of terahertz may almost same with the mid-infrared. But if you combine all, it will be the equation will be decreased. Because you mentioned the influence of cell
Okay.
in favor.
Okay.
But I didn't see that. But that's, I think, the most important one.
In high SCC samples, is there any possibility to split that the cells are deposited on the prism surface? Have you compound?
You mean the cells touched in the silicon?
Yes.
You mean by microscope to confirm? In eyes?
Eyes. If they are strongly attached to the surface, the
eye will be
depth
dirty. Dirty?
The penetration depth will change because the refractive index
Depth
of the
will
sample
change,
will
yes.
change. And as a result, the sample, for example, protein or fat above the SCC may be unclear.
Yes. Unclear, that's why I want to investigate the cell influence. Because cell itself will make some noise. And as you mentioned, the touch or not. Okay, I will think about it.
Any other comment? Okay, we have another time to brush up more. Okay, yeah, thank you very much.